Start review quadratic and exponential functions. We're going to begin with quadratic functions. A quadratic function is a function in the form of f of x equals ax squared plus bx plus c. The graph of a quadratic function is called a parabola. Step 1, we're going to find the attributes of a quadratic function. In this example, we have a parabola that opens up. The arrows are pointing up. We need to find the vertex. Remember that the vertex is the highest or the lowest point of the parabola. Since my parabola opens up, that means that we're going to have a lowest point. So this lowest point is going to be my vertex. Now we need to write the order pair of the lowest point. The x value is -3 and the y value is -1. Is the vertex a minimum or a maximum? Circle 1. Remember that the minimum is going to be the lowest point and a maximum is going to be the highest point. Again, the parabola opens up, so I have a lowest point. That means that we have a minimum. Now we need to identify the axis of symmetry. The axis of symmetry is an imaginary line that cuts the parabola in half. The axis of symmetry is a vertical line, and it cuts through the x-axis, so the equation for the axis of symmetry is going to be x equals. Now, what x value is it cutting through? It's cutting through the x value of -3, so that means that the equation is x equals -3. Now, remember that the x value of your vertex is the same x value that we're using for the axis of symmetry. Now we need to identify the zeros, the roots, and the solutions. Remember that all of those mean the same thing. They all mean the x-intercept. They just want you to find the x-intercept. So we're going to scan our parabola, and we're going to find the order pairs where the parabola crosses the x-axis, and here we have one, and then we have our second one here. We have two x-intercepts, that means that we have two zeros, two roots, and two solutions. So my x-intercepts, or my zeros, are -4, 0, which is the first one, and then the second one is -2, 0. Step 2, writing the function of a quadratic function. Now, this is the same parabola as in step 1. And first we need to find the zeros, roots, and solutions, which remember just means x-intercept. We already found those. The first x-intercept is -4, 0, and then the second one is -2, 0. That means that we have two solutions. Our x-intercepts are going to help us write a function. So once we have our solutions, once we have our x-intercepts, we can go ahead and write a function in factored form. I have two x-intercepts, so that means that I need two sets of parentheses, and each set needs an x. Now, both of my x-intercepts are whole numbers, so we can just go ahead and use the x values of the x-intercepts and put them inside of a parentheses. But remember that your x always lies. So instead of us writing -4 inside of the first parentheses, we're going to write +4. We change the sign. Now we're going to do the same thing with the second x-intercept. Instead of -2, we're going to write +2. And this is the factored form of my quadratic function. Now we need to multiply the factors to write the function in standard form. Remember that standard form is ax squared plus bx plus c. So let's multiply the factors to write the equation or the function in standard form. So we're going to set up our 2 by 2 square because we have two terms in each parentheses, and we're going to write x plus 4 over here and x plus 2 at the top. Now we're going to multiply x times x. Remember that we have understood powers of 1, and when you multiply, you add the exponents. Now, just like the Punnett square, x times 2, positive 2, is going to be positive 2x Positive 4 times x is positive 4x, and 4 times 2 is positive 8. Now we're going to draw the peanut because that means that we're going to combine like. So first we're going to take out x squared. And now we can combine 4x and positive 2x. 4x plus 2x becomes positive 6x. And now we can take out the positive 8. And this is my function in standard form. Now the last step is to write the function in vertex form. This is how the vertex form looks like. Now I dragged it over here so that you can actually see it. It's f of x equals a, which comes from the standard form, times x minus h squared plus k. Now where do h and k come from? Well, they come from our vertex. H is the x value of the vertex and k is the y value of my vertex. So remember that we already found the vertex, which is the lowest point of my graph. The order pair is -3, -1. Okay, so now we need to find a, and we're going to get that from my standard form. A is the number in front of x squared. What is the understood number in front of x squared? It's 1. So a equals 1. So we're going to plug in the a, which is 1. We're going to plug it in into this formula. Okay? So we're going to write the 1 in front of the parentheses, which is my a. And we're going to write x. Now, we need the x value of the vertex, which is -3. Remember that your x always lies. So instead of writing -3 inside of the parentheses, we're going to write positive 3. And then we have the squared. And y always tells the truth. The y value of my vertex is -1, so we can go ahead and write -1.
Hello class, it's Mrs. Mondragon here, and today we are going to be going over the quadratic formula. Before we begin, let's write down the quadratic formula. Our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And don't worry, it's not as scary as it looks, okay? So let's begin. First of all, what is the whole point of the quadratic formula? What is it? Well, the quadratic formula is used to find the x-intercepts, also known as the zeros, roots, or solutions, okay? We solve a quadratic by using the quadratic formula to find the x-intercepts, okay? Please make sure that you write this. It's very important. Alright, so some quick steps to solving by using the quadratic formula. There's 4 easy steps. Step number 1, you want to put it in standard form. So ax squared plus bx plus c. Next, you want to identify a, b, and c. 3, you want to carefully plug into the quadratic formula. So you want to carefully plug in a where it goes in the quadratic formula, b, and c. Then we just need to simplify it to get our answer. Okay, so these are the 4 steps that we're going to be following. So let's go ahead and begin by using those steps. So here they want us to solve the quadratic function. So anytime you see this word solve, that means that we're trying to find the x-intercepts. Okay? And one way of finding the x-intercepts is using the quadratic formula. Okay? So the first step we want to do is make sure that it's in standard form. So if you notice down here we have our steps. So make sure that it's in standard form. So as we look, x squared minus 3x equals 18 is not in standard form. So I'm going to make it equal to 0 by subtracting 18 to both sides. And I'm going to put it right in there. Once I do that, I get x squared minus 3x minus 18 is equal to 0. So that's step 1, and we have now completed that step. Now let's move on to the next step. Next step is to identify a, b, and c. So looking at our function, a is 1, b is -3, and c is -18. Okay, so that was step 2. Now we're ready for step 3, which is to carefully plug into the quadratic function. So in order to carefully plug into it, we need the function. So it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So this is my quadratic formula, and I'm going to carefully plug in a, b, and c. So first I get x equals negative b, and b is a negative 3, so I'm going to plug that in to the parentheses, plus or minus the square root of b is a negative 3. On the outside of that I have to the second power minus 4 times a, which is 1, times c, which is a negative 18. Okay, so all that goes at the top, and then I'm going to put all over 2 times a, which is 1. Alright, so we have now carefully plugged into our formula, so that was step 3. And step 4 is to simplify this. Okay, no big deal, we're just going to take it a step at a time. We have x equals, and at the top I have a negative times negative 3, which will make that a positive 3. So I now change that to a positive 3. I have this plus or minus, I just write that down, the square root of. First of all, I'm going to take negative 3 to the second power. That means negative 3 times negative 3, which makes a positive 9. Now I'm going to multiply negative 4 times 1, which is negative 4, times a negative 18, which makes that a positive 72. Okay? All over 2 times 1, which is 2. Okay, so we've simplified it a little bit. Now we're going to continue this. X equals 3 plus or minus the square root of 9 plus 72. I'm going to go ahead and add that. That makes 81. All over 2. Okay, once I get to this part, now I'm going to address this plus or minus here. Okay, what this means is that I have 3 plus the square root of 81, but I also have 3 minus the square root of 81. So that means I'm going to separate into 2 equations. Okay, the first one's going to say x equals 3 plus the square root of 81 divided by 2. And the other one's going to say x is equal to 3 minus the square root of 81 divided by 2. So if you notice that plus or minus here just means that I'm going to have 2 equations. I'm going to have one with the plus sign in between the 3 and the square root of 81, and one with the minus sign. Okay, so now I can continue simplifying this. I get x is equal to 3 plus the square root of 81 is 9, so 9 divided by 2. On the other side I get x is equal to 3 minus the square root of 81 is 9, so I put 9 all over 2. So I can simplify that a little bit more. I get x is equal to 3 plus 9 is 12. Divided by 2 is going to give me 6. So x is equal to 6. That's one of my answers. On this side I have 3 minus 9, which is going to be a negative 6. Divided by 2 is going to make that x equals a negative 3. Okay, so this right here are my answers. And those right there are my x-intercepts, where this quadratic function up here touches the x-axis. Okay?
In this video, we will cover factoring. When do we use factoring? When a quadratic function is given in standard form and we need to find the solutions, or in other words, the x-intercept. Let's take a look at example number 1. We need to factor 4x squared plus 16x equals negative 16. Step number 1, we need to make sure that our equation is in standard form. So if you look at this example, it is not in standard form, we need to move the negative 16 over to the other side, and we're going to do that by inverse operations. So we're going to add 16 on both sides. Now I cannot combine 16 with 4x squared or 16x because they're not like terms. So now we're going to bring everything else down. 4x squared plus 16x plus 16, and we're going to put that equal to 0 because negative 16 plus 16 is 0. Now, step number 2, we need to check if we can find a greatest common factor. We want to try to find our greatest common factor so that our job can be a little bit easier. We can factor out that GCF and we can work with smaller numbers. So let's see, is there a number that goes into 4 and 16? There is, and that number is the number 4. So now we're going to take each term, okay, and we're going to divide it by 4. Okay, so we're sliding out the greatest common factor, and now we're dividing each term by 4. 4x squared divided by 4 is 1x squared. Now, 16x divided by 4 is positive 4x. And last, 16 divided by 4 is positive 16. Now remember that all of these equals 0. Okay, now step number 3. We're going to use the box method to factor. Okay, so we need to identify a, b, and c from what we have inside of the parentheses. A is a number in front of x squared, which is 1. B is in front of x, so 4. And then c is a constant. Oops, and instead of writing a 4, I wrote a 16, but remember that we are dividing. So we're going to write c equals 4. All right, now let's go ahead and set up our box. Ax squared, which is 1x squared, goes in this box. C, which is 4, goes in this box. Okay, now we need to find the two numbers that when you add them together give you positive 4x. So this is how we're going to do it. We need to identify first what AC is. So we're going to take A and we're going to multiply that by C. So we're going to take the number 1 and multiply it by 4, and that gives me 4. Now we need to write a list of the factors of 4. So we can take 1 and multiply it by 4, negative 1 by negative 4, 2 times 2, and negative 2 times negative 2. But which pair are we going to pick? Well, please remember that we're going to pick the one that when we add them together gives us positive 4. So when we add all of them together, the pair that gives us 4 when we add them together is 2 and 2. So remember that we're going to write them inside of the boxes. So they're invited to the party, and they're going to take their variable with them. And in this case, they're going to take their x with them. So we're going to write positive 2x and positive 2x. Now we are ready to factor. Let's begin with x squared and positive 2x. What goes into both 1 and 2? That's the number 1. That's the greatest common factor. Now, since both terms have an x in common, we're going to take out the x. Now let's go on with positive 2x and positive 4. They have, the number 2 goes into 2 and 4, so we can factor that out. And then we don't have an x in common, so we don't need to take one out. Now, since both 2x and 4 are positive, we can go ahead and write a plus outside. Now we're going to look at x squared and positive 2x. 1 goes into 1 and 2, and I take out the x because they have an x in common. And last, 2x and 4. Positive 2 goes into positive 2 and positive 4. And we don't take out an x because they don't have an x in common. Now we can write our factors in parentheses. So please don't forget about the 4 that we factored out earlier. Okay? So we're going to begin by writing that 4. So we have 4 parentheses x plus 2 times the second parenthesis, which is going to be x plus 2. Now remember that that is the same thing as 4 times x plus 2 squared. Okay, we're multiplying x plus 2 2 times by itself. All right, now we can go ahead and identify the y-intercept. the x-intercept. So we're going to take whatever is inside of the parentheses and we're going to set it equal to 0. So let's go ahead and write x plus 2 equal 0. Now we're going to solve for x. So we get x equals -2, and that is my solution. That's my y-intercept. Take a look at example number 2. We need to factor 4x squared equals 16. Step number 1, we need to make sure that this is in standard form. It's not in standard form, so let's subtract 16 on both sides, and we get 4x squared minus 16 equal 0. All right, let's go ahead and see if we can factor anything out. The greatest common factor. All right, we have 4 and 16, so the number 4 goes into both, so we can factor out the number 4. So we're going to write 4 times 4x squared divided by 4 is 1x squared, and -16 divided by 4 is -4. Okay, we're ready to use the box method for what we have inside of the parentheses. So we need to identify A, B, and C. Okay, A is very easy. It's in front of x squared, so A is 1. But what about B? We don't have an x over here. So let me rewrite this, okay? So we have an x squared. Whenever you don't have an x, that means that the number in front is 0, because 0 times x is 0, okay? And we have the -4. So that means that B is going to be 0. Now, C is going to be -4. Don't forget about that negative sign. Now we're going to set up our 2 by 2 box. And x squared goes in the first box. And we have -4 in the last one. Now we need to find the 2 missing numbers. We need to find AC. So we're going to take A and multiply it by C. 1 times -4 gives us -4. And now we can make a list of the factors of AC. We can multiply -1 times 4, +1 and -4, -2 times 2. All right, those are my factors. Now remember that when we add them together, they need to equal 0. Our lucky numbers are -2 and 2, so remember that we write them with their variable, so they're going to take their x. We have -2x and +2x. Now we're ready to factor. 1 goes into 1 and 2, and we have an x in common, so we take out the x. Now over here we have -2 and 4, so the number 2 goes into both, and we're going to take care of the sign at the end, okay? We don't have an x in common, so we don't factor 1 out. Now let's take care of x squared and -2x. 1 goes into both 1 and 2, -2, and we take out an x because they have an x in common. Now the last one is 2x and -4. The number 2 goes into 2 and -4, but we don't take out an x because it doesn't have an x in common. Now we need to check our signs. 1 times 1 is +1, so I'm going to put a check mark. That means that we're not going to change the signs anymore for those terms. 1 times 2 is definitely +2x, so that means that I'm not going to change the sign anymore for my 2. Last, we have 2 times 1x. That does not give me -2x, so I'm going to add the negative sign in front of the 2 because that's the only one I can change. And then last, we have -2 times +2. That gives me -4, so we're finished factoring this out. Now we need to write all of our factors together. Do not forget about the 4 that we factored earlier, okay? So we're going to write 4 parentheses. We have our first factor, which is x minus 2, times the second factor, which is x plus 2. Now remember that in order to find the solutions, we're going to get the x values inside of the parentheses, okay? And we're just going to switch the sign because your x lies. So instead of having negative 2 over here, I'm going to write 2. And instead of having positive 2, we're going to write negative 2. So these are my solutions.
Hello guys, it's Mondragon here, and we're going to be looking at the booklet Quadratic and Exponential Functions. In this video, we'll focus on page 5 and 6 of your booklet. Okay, 5 and 6 will concentrate on exponential functions. So let's start with the definition of an exponential function. An exponential function is a function in the form f of x equals ab to the power of x, where the input x is an exponent. So x is in the exponent position. So now that we know that, let's take a look at step 1, finding the attributes of an exponential function. So we have our exponential function equation right here, y equals a times b to the power of x. And we're taking a look at this function, y equals 2 parentheses 3.5 to the power of x. So because this equation is in this formula, we know that this is an exponential function. And we also know what our a and our b represents. So to begin with, our a is 2. So I'm going to label that here. And our b is 3.5. Now, our next question is this a growth or a decay? Well, looking at our a value and our b value, I know that this is a growth. And the reason I know that this is a growth is because of my base. So here where it says, how do you know it is a growth or a decay? We're going to say that we know it is a growth because our base is greater than 1. So we know, so that's how I know I have a growth function in this situation. Now let's take a look at what the y-intercept is. The y-intercept is 2. And I know that my y-intercept is 2 because my y-intercept is represented by the a value. So the y-intercept is equal to a in our equation. Okay, now to answer the other questions, the domain, the range, and the asymptote, I need to look at the graph of this exponential function. So I'm going to look at the graph on my calculator. So I'm going to take this equation and graph it. So from my calculator, I'm going to go to a new document. I'm going to add a graph. And I'm going to enter in the function 2 parentheses 3.5, oops, 0.5, close my parentheses, to the power of. So we're going to use this button right here by the x squared button. And that's our caret button. That'll allow me to put x as the exponent position. Now that I have that in, I can press enter and I have my exponential function. So now that I have my exponential function, I can determine the domain, the range, and the asymptote. So I will go back to my PowerPoint and do that now. Okay, so for the domain, we know that we're looking at the x-axis for our domain, and this function will continue to the left side forever, and it will continue to the right side forever. So we know that our domain for this function is all real numbers. For our range and our range, I need to know what my asymptote is. So remember, the asymptote is the line that the function gets really close to, but it never touches. So in this situation, this function is getting really close to the x-axis, but it's never going to touch it. So I need the equation for that x-axis, which is y equals 0. So my asymptote is y equals 0. So that means if you look at the parabola and we look at the y-axis, it's going up forever, but it's not going to go down because it's not going to go past y equals 0. So that means that it's all of the numbers that are greater than 0, but not equal to 0 because I don't actually go to the asymptote. Okay, so that takes care of our first example. Let's go to example 2. For example 2, I want to take a look at the function y equals 2, parentheses 0.5 to the power of x. And I want to identify my a value and my b value. So first of all, I know that my a is 2, so a represents 2. and my b represents 0.5, or you can also say 1/2. Okay, so remember from earlier, if I want to know if this is a growth or a decay, I take a look at my base. So since my base is 1/2, this is going to be a decay, because you have a decay when your base is between 0 and 1. The y-intercept is represented by our a value, which is 2. So that means that our y-intercept is 2, and that's where it will cross on the y-axis. Alright, now again, to determine domain, range, and asymptote, I need to look at my graph. So I'm going to do that now, and I'm just going to go ahead and pull the graph up so you can see that. Okay, so I pulled up my graph, and here it is. I got that from my calculator. I entered in exactly like you see here, 2 times 0.5 to the power of x, and I got my graph. And if you notice, my graph is decaying. And if I look at the x-axis, it will continue going to the left forever and to the right forever. So that means that my domain, again, is all real numbers. And now for the asymptote, because that's what's going to help me get my range, okay? So for the asymptote, if you look at this function, it is getting really close to the x-axis, but it is not actually touching the x-axis. So I need the equation for that line. So the asymptote is the x-axis, which is the equation y equals 0, because all through the x-axis, y will always be 0. That's why that's the equation for the x-axis. So that means that I will never go past 0 for my range. But for the range, you have to look at the y values and see if the y values are going up or if the y values are going down. Well, this function, if you notice, all the y values are positive. It doesn't go to the negative y values. So that means that my range will be all of the y values that are greater than 0, but not equal to 0. Okay, not because this is a decay means that my range will be less than 0. The decay just means that the function is going down, it is decreasing, but the numbers, the y values, is all the positive y values. Okay, so don't get that confused. Alright, so now that we've gone over example 2, I just have one more little thing to go over with you. Okay, so this is very important. Remember that the exponential function is y equals a times b to the power of x, where a represents the initial amount. So when you're dealing with a real-world problem, a is your initial amount, okay? It is known as your y-intercept, okay? So anytime you have an initial amount, like you're beginning with this, that is your a. Another thing is our b. Our b represents the growth or decay factor, which tells you your growth, what factor you're growing by, what factor you're decaying by. But if you have a real world situation and you're trying to find your b value, you have to take your growth factor and add it to 100 to the percent rate that they give you. Or you have to take your factor and subtract it from 100 from the decay factor that they gave you. Okay? So if it's growth, you're going to add 100, and if it's decay, you're going to subtract from 100. Okay? X will represent the number of times the growth or decay factor is applied, and y will represent the result of applying the growth or the decay factor that many times. Okay? So your x usually is time in a real world situation. Okay? And then y will represent your total or whatever that represents. Okay, guys, y'all have a great day, and you are now done with your first booklet. Bye-bye.